Hello everybody, I'd like to talk about the theory beyond the sum of squares calculations for the ANOVA analysis, which means that what is the meaning of the formulas that we are using in order to calculate for the SS total, for example, or SS for group A, or the SS between the groups, or the SS for the error. This is the purpose of this presentation. I will talk about this subject by utilizing this question. Calculate the sum of squares. We need the SS between and SS within. For the three groups in the table below, use the theory for these calculations and verify your result. So first we need to make the calculation, and then we need to make a verification for our results. So we have here three groups, group A and group B and group C, and for each group we have what's called the observations. This is the observation related to group A. These are the observations for group B, and these are the observations for group C. So first of all, the first step to understand the theory behind the calculations, we need to understand the calculation of the sum of squares total, or the SS total. First, this drawing shows the scattering plot for all the observations for groups A, B, and C. For example, this observation here is the first observation for group A, which is 5. This observation here is the second observation for group B, which is 6. And so on. The understanding of the SS total. The SS total is simply represent the variability, or the variation, or the scattering of the observations. So the first step to determine the value of the variability of these all observation, is to get the grand mean for all of the observation for the three groups. Regarding to the formula we are using to calculate for the SS total, this is the formula how to calculate for the SS total. The understanding for this formula represent the summation of the observation, each observation, minus the grand mean, or the average for all the observation, squared. So this is a measuring of the variability of the observation from the grand mean. So first of all, we need to calculate for the grand mean, and the grand mean here means the mean for all the observation for groups A, B, and C. If you sum up all of the observations, you will get 98, and in order to calculate for the grand mean, simply we divide the total observations, which is 98, by the number of observations, which are 15. So the red line in the diagram shows the grand mean, which is equal to 6.533. Again, the measuring of the SS total represent how much the scattering or the variability of these observations from the grand mean. So if the variability or the deviation of these observations is great, so the SS will be great. Otherwise, it will be less. The first step to calculate for the SS total is to determine the deviations between each of these 15 observations and the grand mean. For example, for this observation, which is the first observation in group A, which is 5, this is the plotting of this observation, and this is the line for the grand mean. So the distance between this observation and the grand mean is simply the distance of this line. So in this table here, we have here the observations, and here we have the grand mean, which is 6.53. So the first procedure is to calculate for the difference between the observations and the grand mean. So for this first point, for group A, which is 5, this is the grand mean. The grand mean is greater than the observation, which is x. So x minus the grand mean will be negative, minus 1.53, which means that the this observation lies below the grand mean line. If you try to calculate the sum of all of these deviations, you will get 0. So the summation of x sub I, which is an observation, minus x double bar or x grand mean should be equal to 0. So this formula is not preferred to use in order to calculate the variability of the observations from the grand mean. So the way how to get a value is to take the square of these deviations. So we add here a new column which represents the square of the deviation between each observation and the grand mean, and the total of all of these squared deviations, which is 43.73, is the SS total. So the understanding of the SS total is simply it represents the scattering or the deviations between the observations from the grand mean. If the scattering of the observations is great, so the value of the SS total will be great. Otherwise, it will be less. So this is the meaning of the SS total. Now the second step is to calculate the sum of square within groups, which is represented by SS within. We need to calculate the SS within group A and SS within group B and SS within group C. So let's start with sum of square within group A. These are the observations for group A, and this is the formula we are using to calculate for the sum of square for group A. Simply this formula tells us that the SSA means the total of the squares of the observation minus the mean of group A. So this is a measure of the variability between the observations for group A from the mean of group A. So this is the scatter plot for group A. This point here represents the first observation, which is 5. The second point here is 4. The third one here is 6. The fourth one here is 4. And the last one is 7. So this is the shape of the scattering of the observations for group A. So it is clear that we need to calculate first for the mean for group A. So the calculation for the mean for group A, mean for group A represent the total observations for group A divided by the number of observations for group A. These are the observations for group A divided by the count of the observations for group A, and the value of the mean for group A is 5.20. So for group A, the total observation is 26. The number of observations is 5. So the mean is simply 5.20. The red line in the diagram here represent the location of the mean for group A. So the meaning of the SS within group A represent here how much the deviations or the scattering of the 5 observation from the mean of group A. So in order to count for the variability, first we need to calculate for the deviation between each observation from the mean. For example, this observation is the first observation is 5 and the mean is 5.2, so the deviation is minus 0.2. So for this point or for this observation, the deviation between this observation from the mean is simply 0.2, and the minus here represents that the observation is less than the mean, or it lies below the mean line. Again, if you try to take the sum for all of these deviations, it will be 0. So this is not a good measuring of the variability. So to solve for this, we take the square of all of these deviations and take the sum of all of these squares of the deviation, and simply it is 6.80. So this is the meaning of the SSA. So the SS for group A represent the variability or the deviations between the scores and the mean for group A. By the same technique, the same way, we can do it for group B. These are the observation for group B, and these are the scattering plot for group B, and this is the meaning of the sum of square for group B, which is simply a measuring of the variability or the distance between each observation in group B from the mean after square it. So we need to calculate for the mean of group B. So the total observation for group B is simply 35, and number of observation is 5. So the mean is 7.00. So this line in red represent the line for the mean of group B. Now we need to find the variability, which is simply represent the distance between each score in group B from the mean. So for the first point, which is 7, this point here, it is same as the mean, so the deviation is 0. If you try to sum up all of these deviations, you will get 0. So we need to take the square of all of these deviations. So we add a new column here, and taking the sum of all of these value, we'll have the value of the SS for group B, which is 10. So this is the way how to get the sum of square for group B. The same way for group C. These are the observations for group C, and this figure here shows the scatter of all of these 5 observations, and this formula here tell us that the meaning of the sum of square for group C is simply a measuring of the variability or the distances between each observation from the mean for group C. So the same technique we need to calculate for the mean for group C. So the mean for group C, the total observations, which are these observations divided by the number of observation, which is 5. So the value of the mean is simply 7.40. So the total observation is 37. The number of observations is equal to 5. So the mean is equal to 7.40. So this line here in red, the horizontal line, represent the line for the mean of group C. So the sum of square for group C or within group C represent how far the observations are from this line. So first we need to calculate the distances between each point from its mean. So we should have a column for x minus mean, and if you try to calculate the total here, you will get 0. So we need to square these distances or these deviations by adding a new column here and square all of the observation, and taking the sum of all of these squared of the observation, we'll get the sum of square for group C, which is 13.20. So these are all the calculation for the sum of square within group for group A, group B, and group C. The sum of square for group A is 6.80. For group B it is 10, and for group C it is the highest, which is 13.20. So the variation or the variability for group C is the highest, and the variability for group A is the least. And in order to calculate for the total of the SS within, which is simply the sum of square for the error, we should sum all of these sum of squares. SS for A and B and C. This is for A, this is for B, and this is for C. So the sum of square within, or the sum of square for the error, is simply 30. So by this, we have calculated the SS total and the SS within, or the SS error. The remaining calculation is the SS between groups. So the third step is to calculate the sum of square between groups, which is abbreviated by SS between. And the formula we are using to calculate for the sum of square between is simply summation of n sub I, number of observation, multiply by x bar sub I, which is the mean which the observation is belonging to, minus x double bar, which is the grand mean, all squared. For example, to calculate for the, or what's the meaning of the SS for this point? This point is the first point, which is belonging to group A. So for group A, this is the mean of group A, which is 5.20, and this is the grand mean, which is 6.533. So for this point, the SS between group for this point is the distance between the mean of group A and the grand mean. So it is simply this distance. So for the second point, simply it is the same. So we have this distance. For the third observation in group A, this is the distance. For this observation here, this is the distance. And for the last one, this is the distance. So all of these 5 distances are the same. So what's the total of these distances? We have 5 distances multiplied by the mean for group A, which is 5.20, minus the grand mean, which is 6.533, we square it. The same way for the observations for group B, and the same for the observation for group C. So the meaning of the SS between here represent the deviation between the mean of each group and the grand mean. So if you proceed, you will get the value of the SS between groups to be 13.732. The last step is to make the verification of our results. These records or results in these two tables are come from the using of the Excel. So in this table, the top table here we have some descriptive statistic for groups A, B, and C. For example, for group A, we have 5 observations. The sum of the observation is 26, so the average is 5.2, and the variance for group A is 1.7. The table below here represent the one-way ANOVA table, which is again by using the Excel. For the one-way ANOVA, we have two sources of variation. The first one is the between groups, and the other one is within groups, which is the same as the SS for the error. So the SS between group is 13.73, which is same like what we got, and within groups or the error is simply 30, same like what we get, and the total is 43.73, same like what we get. This is the degree of freedom for the between groups. We have 3 groups, so 3 minus 1 is 2. Within groups or the error, simply the total observation, which is capital N, which is 15, minus 3. This is the calculation of the mean square. This is the calculation of the value f. To calculate for f, we simply divide this value by the ms for the error. This is the value of the probability for the value of the calculated f, which is 2.747. And this p-value means that the area in the f distribution right to the value of f equal 2.747 is 0.104. So the probability is greater than 5% and also greater than 2% and also greater than 1% and also greater than 10%. So we don't have any significance here, simply because the value of f is is less than the f critical. So the hypothesis related to these groups, the conclusion is to accept the null hypothesis, which means that the three means of the 3 groups, groups A, B, and C, are the same. These are the understanding of the calculations for the SS. Thank you for your watching. Goodbye.